All right, I guess like everyone knows the gag now, I turn on a signal generator, get a tone coming out there, and then I go, Happy birthday to you. Happy birthday. Well, okay. Uh, Very funny. I'm here to tell you I can do better. So the back of the generator has an input. It's called VCF, and that stands for voltage controlled frequency. All right, so I'm going to go ahead and put a connector into the VCF input. And so I've got these alligator clips that are connected to that. All right, and this is a power supply which provides a DC voltage that's adjustable. I'm going to go ahead and turn this down, and we'll connect the VCF input to one of these outputs from the DC power supply. Okay. Okay, so we'll go ahead and turn this on. And okay, so here we've got a frequency. Now we'll go up to the DC power supply. Let's turn it on. And we'll adjust the voltage. Turn it on. And so now adjusting the voltage changes the frequency, and I can like do a happy birthday to you. But that's not exactly what we're going for. Okay, so I've hooked up these two meters here. This particular one is set to measure voltage, and this one is set to measure frequency. We'll go ahead and turn on the generator. And I'm going to set this for about, well, I've already set it for about 200 hertz. So for the range that we're going for, that's a good start point. And I'll turn on the DC supply. So at 0 volts, we've got about 200 hertz. And we're going to run this up to about maybe 500. Well, it's not that important. So notice that we have 524 hertz and 3.463 volts. Okay, we're going to do a little quick math here. So what this means is that if we put these voltages into the back of the generator, into the VCF input, these are the frequencies that we're going to get out, which correspond with these particular notes. This is my programmable logic controller, and this particular module is what they call a D to A converter. It takes a digital number and converts it to an analog voltage. The output runs anywhere from 0 to 10 volts, depending on what the input is. So that means we'll have one more step with this now. We're going to want to create one more column for the PLC input count, I guess we could call it. And this is basically going to take this voltage and convert it into a binary number. So that's a 12-bit register, meaning that it can count from 0 to 4095. At 0, it would be 0 volts out. At 4095, it would be 10 volts out. So yeah, a little quick math. Okay, so this is the PLC program I just wrote, and each one of these little boxes is going to correspond to a note. You'll notice this is like 250, 387, 542. Well, if we go back and take a look at our spreadsheet, those are the same numbers that we're seeing here. That's the PLC count that's going to generate that particular note. So, oops, I didn't want to do that. Anyway, every time we close one of these contacts here, that's going to turn on that particular node. And the way these contacts are closed are by something called a drum, which is basically it's kind of a sequencer that goes line by line by line, turning on particular numbers um, that correspond to the contacts that are turning the notes on and off. So that's about it. I guess we're ready. Oh, right. I guess there is one more thing, and that is that we got to hook up the hardware. All right. Well, this won't take long. Happy birthday to you. Happy birthday to you. Happy birthday, dear Barbara. Happy birthday to you. Happy birthday to you. Happy birthday to you. Happy birthday, dear Barbara. Happy birthday to you. Happy birthday, sis.